everyone, we are moving on to Unit 6, which is Law of Cosines, and a little bit of right triangle review. So to start, they give us a right triangle, they give us an angle, the opposite side length, and they want us to find the other measures of the triangle. So first things first, I can find the measure of this angle here, because triangles. So this must be 63 degrees. Okay, then in finding the side lengths of B and C, we have a few options here. It's probably easiest to use sine. So I'm going to say that sine of A is equal to little a over little c, meaning that sine of 27 is equal to 31.4 over c. Okay, so solving for c, make sure your calculator is in degrees here. Solving for c, I end up getting 69.164. Okay, then solving for b, we can use sine, cosine, or tangent if you want. Alternatively, you can just use the Pythagorean theorem. So I know that b squared plus 31.4 squared is equal to 69.164 squared. So b must be 61.625. Okay, so those are your options, but tons of different ways to solve this. Okay, next example, this time they do not give us a picture, so we'll draw one ourselves. So they say that in PQR, Q is my right angle, Q is 147.6, R is 72.15. They want us to find the measures of the angles. So a few different ways we can do this. You can solve for P or R first, it doesn't matter. Because again, you can just solve for QR using the Pythagorean theorem, but I'm going to go ahead and solve for R first. So I know that sine of R is 72.15 over 147.6, and then we're going to use arc sine in our calculators, and we end up getting that R is 29.263 degrees. Okay, solving for P, I can just again subtract and find the complement. So P must be 60.736 degrees. And using the Pythagorean theorem, I know that 72.15 squared plus P squared must be 147.6 squared. So P must be 128.763. Okay, let's investigate the law of cosines. So you've actually been using the law of cosines ever since you learned the Pythagorean theorem, because they're essentially the same thing. What we have here is the first part, which should look very familiar. It is exactly the Pythagorean theorem. Okay, from there we have minus 2b cosine A. So the way that I remember this is that my side length here always corresponds with my angle. Okay, so B is to B, C is to C, and then the other two side lengths of the triangle are what comprise the rest of the equation. So if I'm using A on the left of my equation, if I'm solving for A, that means I'm using angle A, then B and C comprise the rest. So B and C make the Pythagorean theorem, minus 2BC cosine A. Okay, now what happens if angle A is a right angle? So if A is a right angle, and I plug that in, cosine of 90 is 0. So this entire part of the equation will cancel out. I'm just left with A squared equals B squared plus C squared, which, as you all know, is the Pythagorean theorem. Okay, so let's figure out how to actually use this. First, they want me to find A. Okay, well, I know that A squared is equal to B squared plus C squared minus 2BC cosine of A. So I'm just going to plug in. So I have 5 squared plus 7 squared minus 2 times 5 times 7 cosine of 39 degrees. Just plug that in your calculator. Do not forget to square root everything because A is squared. And we end up getting that A must be 4.427. Okay, exact same thing, except they didn't give us a picture. They want me to find the side opposite the given angle, which is great because that makes it easy for me, because I know that if I use my a squared formula, I will have my angle right here. So a squared must be, I'm just going to use the other side length of the triangle here. So 4 squared plus 5 squared minus 2 times 4 times 5 cosine of 51. Okay, again, we plug this into our calculator. Again, do not forget to square root everything. And a must be 3.978. Alright, moving on. They give us triangle XYZ. Okay, I have x being 3, y being 7, z being 9. They want me to find the measure of angle z. So since I'm solving for angle z, I probably need to use side length z on the left side of the equation. Because this is what I want in the equation. If you use any other side length, you will not end up with this angle. So now I just plug in. So 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine of z. We want to simplify, subtract these, divide, and then use arc cosine. Okay. So we end up getting the measure of angle z being 123.203 degrees. Alright, last example. Exactly the same thing. They want us to find the measure of our angle, so I'm going to use the same formula. So I'm going to plug in z is equal to 3 squared plus 7 squared minus 2 times 3 times 7 cosine of z, which is what I'm solving for. And again, we are going to reduce, and something weird happens here. I end up getting something undefined. So then I have to look at the information they gave me, and if we paid attention, we would have noticed that the side lengths of 3 and 7 cannot have another side length of 11. Hey, this cannot make a triangle. It's impossible. 3 and then 7 and then 11 is too long. So this side length will never connect and make another vertex. So that's why I ended up getting an angle that doesn't exist, because this is not a triangle. Okay, so be careful about that. If you get something that doesn't make sense, just check and see that you have all the correct information, just to make sure that you didn't make a mistake. But in this case, this is impossible, so z is undefined. Alright, that's it for these notes. If you have any questions, let me know, and I will see you all later.